Okay, again, we're doing over probability distribution. And what we have to figure out is our expected outcome, so the amount of money we're going to make. This stands for probability of said event, and that has to do with the number of outcomes in an event. And the expectation is you can say the winnings, or the amount you'd win, times the probability and how many different outcomes there are in total, n standing for the total number of outcomes. And this is a summation notation, which you're used to. The question asks us, a lottery has $1 million first prize, so one prize of $1 million, a $25,000 second prize, and 5 $1,000 third prizes, with a total of 2 million tickets were sold. Okay, what is the probability of winning a prize in this? Okay, we know that we have $1 million as our first one chance at $25,000, and then we have 5 chances at $1,000, which means we have a total of how many chances? 7. How many tickets were sold?
2 million.
Okay, so assuming this lottery number of outcomes would be 2 million, right? Assuming this lottery is a fair lottery, we have 7 total chances. You have a 7 in 2 million chance of winning a prize in this lottery. The second question says, if a ticket costs $2, what is the expected profit per ticket? Okay, well, expected profit, that deals with how much we're going to make and the probability of making it. So the probability of winning $1 million is actually 1 in 2 million. Okay, I'm just going to use dots to write million after. Probability of winning 25,000 is, again, 1 in 2 million. And the probability of winning $1,000 is technically, there are 5 chances at it, so we're going to say 5 times. You still only have a 1 in 2 million chance of winning each. So you could say 5 in 2 million in that case. But for expected outcome, right, we got to take our expected winnings. Well, our winnings in the first one are $1 million times our 1 in $2 million, or 2 million chance. So that's our first expected outcome. The second expected outcome we'd add to is $25,000, all times our 1 in, I'm just going to use that as a 2 million. And finally, we have 5 chances of winning $1,000. Let's try to move this over just a little so we can read it up. There we go. We have 5 chances of winning $1,000 with still a 1 in 2 million chance. So we're going to multiply these together. Million over 2 million is the same as 1 over 2. 25,000, and I guess we'll use our calculator so you can see this. 25,000 over 2 million, so divide 2 million. 0.0125, which is 1 over 80. We figured out earlier. And in the last one, it's 5,000 over 2 million, which is what? 1 over 400, right? So we just did these as fractions. We add our equivalent fractions, and we found out we got 206 over 400, which as a decimal was 51.5. Remember, this is in dollars, right? Because all of these winnings were dollar values. Sorry, it wasn't 51, it was 0.51. Couldn't be 51 because it's 206 is less than 400. So it was 0.51. So in other words, as a dollar value, we're looking at 0.5, and we can round this value up or down. Let's say up, 52. So your expected winnings is a total of 52 cents every ticket. You expect to win 52 cents every ticket. But they told us that every ticket was $2. So what we're going to do is our winning minus our losing, and that will give us our profit per ticket, because the question asks what's our profit. Well, if we expect to win $0.52 every ticket, but we know every ticket costs $2, our expected profit will be 0.25 subtract 2. 0.52 subtract 2 gives us negative 1.48. Negative 1.48 as our expected winnings. So we expect to lose $1.48 every time we buy a ticket in this lottery. That makes sense.
Yeah.
A lot clearer, right?